Audio Jungle. Audio Jungle.
So, right. So, whenever you will talk about the lateral stability, correct? Lateral, it is already explained that lateral stability always relates to the rolling moment. You had seen that we had that aircraft, no, that diagram, if you remember. See, this was the diagram for the aircraft. This was the diagram, correct? And suppose here we have a wing. Check. This was the wing for the aircraft here. So the direction of the airplane, see, this was the longitudinal axis. Remember, longitudinal axis, correct? And I also had shown along the wing. This was this was the, remember, it was the lateral axis. Check everybody. So longitudinal, lateral, and third one was the just perpendicular. Okay. So perpendicular, I can show here. This is the just perpendicular to the page, or that will be the top, and also you can show by the bottom. So I can take this one. If it is visible to you clearly, this will be the basically, check this, the one axis. It is bottom or top also you can say. So this is the lateral axis. This is the longitudinal axis, and this will be the directional axis. That has directional. Okay. So for this directional axis, I will show another diagram. So it will be clear. This is the airplane now. So this axis, if I say where is the directional axis, so that directional axis will be this one, the top and bottom. So about this directional axis, whatever the moment called, say yawing moment. Correct? Right. So this is nothing but directional. Right. So now if you talk about the lateral stability, okay, talk about the lateral stability. So lateral stability always comes and it relates to the rolling moment. And that rolling moment, if you check, this is the lateral axis, this is the longitudinal axis. So the rolling moment always about the longitudinal axis. If you talk about this axis, longitudinal axis, so we'll have a moment. Moment. Right? So rolling about the longitudinal axis. So in this situation, this right side wing called starboard. What it is called? Starboard. And this side wing, left side, it's called port wing. Left wing is called port wing. This is the right wing, right side wing, right side wing or left side wing. That you have to say. So right side wing called a starboard. What it is called? Starboard. Please remember this. It is very important. Okay. And left side wing will be called as a port wing. So in the case of the rolling moment, you can think aircraft will roll about the longitudinal axis. So that means that starboard may be go up and port will go down, or just opposite, wing will go up and starboard will go down. Then only you will get the rolling moment, and it is always rolling moment always because of the this component which is called as a aileron, because of the aileron, correct? Because of the ailerons you will get the These are the information. Okay, single marks question can be asked to you. So if laterally it is unstable, when it will be unstable, I will tell you. When laterally it is unstable, so that time the wing, which is starboard and port wing, okay, one will go up, one will go down, and that also again because of the disturbance there will be the unwanted rolling. You actually intensely you don't want that rolling, but because of the disturbance that aircraft will roll about the longitudinal axis. Okay, so to make it stable you will use the control surface, and that control surfaces are nothing but ailerons. And that already I have explained you. Ailerons, correct? Ailerons, no? Ailerons both side. Ailerons, correct? Ailerons. So these ailerons, here we have a control surface for the lateral stability, for the rolling moment. So in lateral stability, in short, what I have to say, I will write this. You please follow. Lateral lateral stability. Once lateral comes, then it relates to the rolling moment. It relates to the rolling moment. When there will be the rolling moment, this rolling moment is generally denoted by capital L. Please make a note of it. And this rolling moment is generally actually about the longitudinal axis. About the longitude, about longitudinal axis. Okay, and here the control surface. Talk about the control surface. It's nothing. Ailerons, right? Ailerons. I hope you understood this. Huh? So generally, whenever you will have a rolling moment, that rolling moment means one wing will go up, another wing will go down. I have told you starboard and port wing. So I'll show you. This is the front view of the airplane. Here I'll show, because ailerons is what mounted on a main wing only. So I will show you the main wing only. Till earlier I was doing continuously that tail, because the elevator was placed on the tail. But now elevator part is what over. No, it was pitching moment. So pitching moment part is over. Now we are going to talk the rolling moment. So for this rolling moment, basically we have a main wing, and on main wing there will be a control surface which is called aileron. So if this ailerons, if you mount here, check, obviously it will be mounted here. So think about it. This is, suppose the ailerons, here it is deflected up. So to make it roll condition, this another aileron should be deflected downward. So this, you think about it, you will understood. Okay. So deflected upward this side, deflected upward, and here it is deflected downward. Think about it. Okay. So what will be happening here? Check what will be happening once it is, and you think this is the basically the front view. So whatever the air is what coming, the air is what coming towards the airplane in this direction. Check, in this direction the air is what approaching to the aircraft. This is what the free stream. Think about it. Okay? It will be more clear. Free stream, free stream. Air, no? What air? So if the elevator is what deflected, sorry, the ailerons is what deflected for this aileron. And think about it. You just think this air, this is the aircraft. So this will be the right wing. Say this will be the right wing. I will write RW, right wing, and this will be the left LW. For the airplane, this will be right side and this will be the left. So the right wing called as a starboard. But it is called starboard. And for the left wing, it is called P, port wing. Starboard and port wing. Starboard wing I can write here, or is port wing. Please just remember the short name. Okay. It's not necessary because we do not have a space to write. So I'm writing in short. Otherwise, you write. have space. Okay. So the concern is, if this is the right wing, this side, okay, and this side left wing. Now, if it is deflected upward direction, so, and this is deflected downward. If elevator is what deflected downward, so what will happen? Think about it. If elevator is what deflected downward, so this side lift will be more. Can say lift will be more, right? So this side lift because it is deflected downward. Generally, what is happening? See, flaps and all, it is deflected downward. Why you? Because you want lift. Again, the same condition you can say, because the camber of the wing is what increasing because of the control surface, because it is deflected downward. Okay, surface area increases, so lift increases. So this side lift more. Think about it. Lift, and because it is deflected upward, this one is what, if deflected upward. So here the lift will be reduced because it is deflected in upward direction. So whatever the lift you will get because of the ailerons I'm talking, because of the ailerons talking, that lift will be in downward direction. Better you say that lift will be in downward direction because of the ailerons I'm saying, LA, because lift because of the ailerons, it will be in downward direction. And here, because it is deflected downward, so whatever the lift generated because of the ailerons deflection, that is the LA, it will be in upward direction. Why? Because ailerons is deflected downward, correct? And just opposite to the port wing, if you see the uh, that deflection of the ailerons is what in upward direction, so the lift will be in downward direction. That concept already I have explained for the elevator. When it will be deflected upward and when it will be deflected downwards, what will happen, and in which direction lift will be produced. That already I have explained. So now think about it. Here lift is what in upward direction because of the ailerons, and here lift is what downward. So it's just like a coupling moment. See, it's like a coupling moment in this way. About the CG, it will produce a moment, right? And that moment basically is nothing but the pitching moment. This moment will basically use to roll the aircraft. That will be the pitching moment. I have it. Pitching. This will be the rolling moment. This moment is nothing. Pitching moment. Actually, that fever had not gone yet. Pitching moment. Journalist. Rolling. The aircraft will roll. Why? Because of the coupling moment. Because see, lift LA here. There will be a distance. Let's say this is the C. This distance is what X, and here again this is what LA. This distance is what Y. Actually, it should be placed with the equal distance. There should not be any confusion. X and X I can take both sides because equally it is placed from the CG. Okay. So obviously it will produce a coupling moment. This type of moment called as a coupling moment. Coupling. So this type of moment, the coupling moment will be produced, and this type of moment basically used to roll the aircraft, and this rolling will be always about the axis. That axis is nothing but longitudinal axis. I hope you understood this, correct? So I'll write this positive role, and what is the positive role, what is the negative role, that also I'll explain you. Because just like in longitudinal stability, here also we have a in case of the lateral stability also we have a positive role and negative role kind of things that run. And then we'll go to the same thing will be see, talk about the yawing moment, or if you talk about the this what it is called lateral stability, where rolling moment. So rolling moment and yawing moment in both cases, okay, in both cases, uh, that it may be your moment or it may be roll moment, but in both cases we have a positive and negative. Just like in a pitching moment, there was a negative pitching moment, there was a positive pitching moment. So here also we have to see that criteria you need to remember. Okay, that criteria you need to remember. Rest. Um, okay, so check. If I say if I say the pitching rolling moment, I say the rolling moment is nothing but L. Rolling moment is nothing but L. Just like a pitching moment was M. So here the rolling moment is what L about longitude axis. Okay. Then how the lateral stability will be defined. So I will write the lateral stability. How it will be lateral stability. So how it will be defined. So lateral stability basically now define. Take it. The criteria for lateral stability is positive role positive role should result in negative in negative rolling. Just remind the longitudinal stability pitching moment. Just remind that. So if you relate with this, you will understand. Okay, rolling moment. That means that is ELI. That should be a negative rolling moment. Okay, means this is what means negative means negative. So if TL by T5 is less than 0, which is a negative, is negative. So it will be now it will be considered as a uh, positive roll, positive roll, which means it will give the negative rolling moment, just like in case of the longitudinal stability, that nose up means there was the increment in angle of attack, pitch up or nose up was there. So that if you check, there was the positive nose up, but for the stability criteria, it should be a negative pitching moment, means it should go down. That nose down should be there, so that you will apply the anti-clockwise moment, that restoring moment that was negative. Correct. So similarly here also. Okay. So so that role is the positive role. Okay, positive role. But what is the criteria for the stability? Lateral stability, that negative rolling moment, just like a nose up in case of the, just remind, because if you relate from the longitudinal stability, you will understand. I had explained that nose up condition. So if angle of attack is increasing nose up condition, that means the positive nose up is what positive. But what was the criteria for the pitching moment? The criteria for the pitching moment in longitudinal stability, that it should go nose down. So for that, we had seen there was the restoring moment, and that was the anti-clockwise moment, and that was the negative. So for that reason, you had written dou cm by dou alpha less than 0. Dou cm means what? Pitching moment coefficient means dou m was the pitching moment. Dou m by dou alpha was negative. Same thing is here also. So the role is the positive, but it will give the, if you talk the stability point of view, then it should be, the moment should be a negative rolling moment. Okay, I'll show with the diagram, like how before disturbance and after disturbance, because here also in lateral also we have a three types, na? Stable, unstable, and neutral. So just try to understand this. This diagram, if you see, then you will understand. See, Check everybody. Okay. See here, whatever we are talking, this is the before disturbance. Before disturbance. And this is what after disturbance. After disturbance. Okay. Now just think about it. If if it is the before disturbance, so now the aircraft, obviously before disturbance, the aircraft condition will be somewhat like this. The aircraft now, because we are going to check the roll only. So just like in longitudinal stability, we were checking the nose up and nose down. So here we are checking the roll. Ah, so this is the aircraft actually. Okay, this is what the aircraft. Now think about this aircraft. This is the front view of this. This is what the aircraft check. What before disturbance. I'm going to check the rolling condition. So now see, the aircraft is what like this. This is before disturbance. But once the gust load, or once the disturbance, or once the crosswind came, and that crosswind is what hit to this aircraft, so this aircraft is what rolled. How it is rolled? It is rolled somewhat like this. Check. Earlier it was like this, but this aircraft is what rolled, and it is now like. So here I can say from the vertical, there was the moment. That moment, because of the crosswind or because of the gust, it started rolling. So that rolling is what somewhat like this. See, this wing is what gone down, and this wing is what gone up, and it will be continuous. It will be continuous. See, like this. Maybe here it will be more clear. The I told you this is nothing but from aircraft point of view. This will be the right side wing called called starboard wing, and this will be the port wing. Take it. This will be the port wing. Correct. So it will be going like this. So see, the starboard is what gone up, and port wing is what gone down like this because of the because of the disturbance. So if the aircraft is what laterally stable, think about it, because of the disturbance it is rolled now. But if it is stable, then immediately the uh, restoring moment should be generated if it is laterally stable. So if it is laterally stable, then in the next again you will have the restoring moment, and it comes to its original almost position. Okay. Why? Because see, there will be a restoring moment, and that restoring moment will be just like this. So this is nothing but restoring. So if it is stable, laterally stable, then it will again comes to its original condition. That means it's a stable. Think about it. This disturbance came and there will be a rolling started. It is rolled, but again restoring moment will be generated, and again achieve its original. Okay. So this is the one. Second, if the aircraft is what set at that condition one, is because of the disturbance, it is set with the same location. It is not going away, not going back, not going away, not going back. It is, if it is rolled, then it is fixed at that point. So this will be the neutral. It is not going back, not going away. It's a neutral. With some angle, because of the disturbance, it is rolled. It is rolled, and once it is rolled, then it will be fixed with the same. So it will be tilted. Okay. Now coming to the next one, which is nothing but third. If because of the disturbance, the aircraft is what rolled. Okay, it is rolled. Okay, it is rolled. Then the rolling will be continuous. Okay, then the rolling will be continuous. It is not coming to its uh, it is not coming its original condition. It is not coming back. You can say diagram is not here actually. It's not coming back. Because of this, the rolling is what continuously. See, there is no that aircraft itself not able to come to its original position, not able to come to its original orientation basic. So such type of aircraft is laterally unstable. Laterally unstable. Please remember. So three cases I have shown you. Okay, three cases I have shown: laterally stable, laterally neutral condition, and laterally unstable after the disturbance before. All two cases, all three cases you have. Okay, that you need. Now, if you have a rolling condition, so that roll is all about. So there will be the form, just like a longitudinal stability. There was the angle between the chord line and horizontal line. That was the angle of attack. So from the so that time refer, because it was pitch up and pitch down, nose up and nose down. So the reference angle was measuring from the horizontal axis, or from the reference was the horizontal. But now think this aircraft is what rolling. So if it is rolling, so definitely whatever the reference axis or direction you will take, that will be the vertical. So I can say this is the actual condition of the aircraft without any disturbance. So the aircraft is what somewhat like this. See, somewhat like this is the actual. This is the before disturbance I have to before disturbance. Okay, because see why I'm saying this, because that you should know properly, with the angle and all, where phi angle or side slip angle also sometimes we have to consider. This is the before disturbance, and here we have a after disturbance. Both diagram. After disturbance. So if it is before disturbance, so from the vertical axis, see, you check the vertical axis, and this is horizontal axis. This is before disturbance, right? But once the aircraft is what it is encounter with the disturbance, so the aircraft orientation or attitude of the aircraft will be. So now the aircraft attitude will be seen. Make it more visible. You can say this is the backside tail. Now it is more clear. So now this part, okay, this part, it is shifted with. It will be more clear to you. Okay. So now, as you have seen, this is the vertical. Just now I have shown, and this is what the horizontal. Check everybody. Vertical and horizontal, correct? But now it is changed. Is changed with. Check, check please. This angle. This will be the same only, correct? I hope you understood. Huh? Because it is shifted. This angle we are talking phi angle. This is nothing but phi angle. Okay, phi angle. Hope you understood this diagram. There should not be any confusion. Still, if you have, you can discuss. Na? So this angle is called phi. Angle phi angle is called as angle of roll, or angle of roll, or also it is called, or also it is called, if you remember that physics, na? 10th standard physics, there was the banking angle, that is called banking. Okay, always remember L and phi. L is nothing but moment. What moment? Moment is nothing but uh, basically, because of the disturbance, that moment developed. Because of that only it is basically here shifted with the phi angle because of the disturbance. So it should get back, it should get back to its original. So that restoring moment will be acting like this because of the disturbance. See, this is the, just say this is the crosswind. Think it like this, so you will understand. The crosswind before disturbance. The crosswind was coming like this. But this was the condition before disturbance. And once this crosswind or disturbance comes and hit to the airplane, it is shifted with this. So it is rolled actually. It is rolled. So restoring moment is what required. That is nothing but L. So restoring moment is required. That is nothing but L. And just like if you remember in case of the longitude, the pitching moment was required, restoring moment. That was capital M. This is nothing but capital L. I hope it is clear now. Correct. So see this phi you can say here or this phi. Both are the same only. Both are the same only. Okay. So here you think this phi, generally this side, it is, if you are measuring with respect to vertical axis, then it is a phi. But if you are measuring with respect to horizontal axis, so this will be the beta. Okay, this will be the beta. But magnitude wise it will be same only. Okay, magnitude wise it will be same. That time this beta is called as a side slip angle. Please write down this there. Important, side slip angle. Side slip angle. Okay, it is called side slip angle. So this L is the restoring moment basically. Restoring moment. Every time I will not write this restoring word, because whatever the pitching moment or rolling moment or yawing moment, it is always restoring, because the aircraft is what, because of the disturbance it is dislocated. Now to make it same location, you, the control surface or the aircraft itself, it will try to get back to its original position, original orientation, original attitude, initial attitude. uh, it comes by its own only. Okay, then only you will say this aircraft is what, laterally stable or not. So the restoring moment, which is nothing but the lateral moment, nothing but the lateral moment. Just like a pitching moment. So this is what the lateral moment. So first I will talk about the this phi. If you check, okay, so phi, L is what the moment which is changing with respect to phi. So if you draw the graph, okay, you draw the graph just like there was pitching moment versus alpha. So here we'll have a, see everybody, here we'll have a, check, here we'll have a the moment which is nothing but rolling moment, and this will be the check of phi, which is nothing but roll angle. So again, see here what it is trying to do, because of the disturbance, it is rolled, you say clockwise, anti-clockwise, that is the restoring moment required L. So if you check this anti-clock, so again you just take the same, that will be negative. So this moment should be a negative moment. Restoring moment should be the negative moment. Huh? That roll was the positive. Roll was the positive. See, roll was the positive, but you see the angle wise also, this clockwise angle you can say here. See, this roll was the positive, but it will be laterally stable when there is the negative roll moment. That's the reason it is written here. See, in the definition itself, check the lateral stability, right? See, check this. The lateral stability is positive roll. A positive roll should result in negative rolling moment. So laterally it will be stable if you check the criteria point of view. So the roll will be the positive. What is the positive roll here? If you talk about the aircraft and the front view, so this side it is nothing but a starboard. This is what is starboard, right wing, starboard, and this is nothing but port. So positive roll means what? The starboard go up. This is going up and this is going down. So this type of roll called a positive roll. Huh? But to make it again stable, to get back its original orientation, original attitude of the aircraft, initial attitude of the aircraft, so the rolling moment should be just opposite. That will be the restoring. then only it will again comes back to its original attitude, correct? Initial attitude. I hope you understood now. So now the overall idea, if you talk about overall idea, so what you will write?
Sir,
Check. Yes.
sir, this L can be positive or negative.
In this situation, L versus phi, this is the L rolling moment and this is the phi. So if you draw the graph for this, draw the graph, so you got the gradient. Gradient means the change of rolling moment with respect to the rolling angle. Rolling angle. So you have seen in the previous analysis as well, you have seen that L and phi both are just opposite. So whatever the gradient, whatever the change you will get, just negative value you will. Correct? Because there was the positive rule. The phi is increasing. If you see the previous graph, if phi is increasing here, there is the positive rule. Phi is increasing. But to make it stable, you should apply, or the aircraft should be designed in such a way that it should create a rolling moment which is just opposite in anti-clockwise direction, you can say. If you see the phi change, it is clockwise, but L should be in anti-clockwise. Correct? That is my point here. Just like in longitudinal stability, the angle of attack was increasing. So alpha nose up was there. You can say positive uh, increment in angle of attack, and obviously, but to make it balance, it's the restoring moment was the pitching moment was generated anti-clockwise, so that that nose should be down, so that the angle of attack can decrease. So you had seen that change of the moment with respect to the angle of attack alpha was negative. Correct. I hope it is very clear. Now, so here I will show the basically uh, this change. This is the graph. This is the graph here. This is the graph. Everybody can see. This is the graph. Okay. So this graph is nothing but check. It's a d alpha by dl by d phi, which is less than 0. L by d phi is equal to 0. This is what dl by d phi positive. Correct. So now here you have seen the change should be in this also diagram you can understand. If you check the gradient, if you check the change lateral moment with respect to phi, it is just opposite. So obviously the overall idea is, if this dl by d phi less than 0 we have, then it will be a stable condition. So that the aircraft is what laterally stable. This is laterally neutral, and this is what unstable. Correct. Always remember. Okay, there should not be any kind of confusion there, right? So dl by d phi, I need this should be a negative. That is the laterally stable aircraft. Okay, and if there is the unstable aircraft, correct? You should know that. Huh? Right. I have shown you that with respect to the beta also you can calculate. Na? Beta also you can calculate. So always remember this point, you need to remember. Okay, dl by d phi should be, so the restoring moment changes with respect to roll angle or or banking angle indicates rolling moment changes with respect to roll angle or banking angle is negative, angle is negative for stable aircraft. For stable aircraft. And if you talk about the what it is called that side slip angle, talk about the side slip angle as well. Side slip angle. This is the important point. Side slip angle. Okay. So in the case of the side slip angle, also see the angle is what here. This angle is nothing but beta, which is increasing in downward direction. So beta is what increasing. It is increasing, but to make it initial position again, L should be applied in opposite direction. So that also you can say in terms of the side slip angle. This is the in terms of the dl by d phi. Okay, and in terms of dl by d beta also is sometimes defined, which should be less than 0, which should be less than 0. That means negative 1. Always remember, dear, this type of question they are asking. So this, what they can write, this one also you can write dou cl by dou phi. Okay, less than 0. And this one also can be written as dou cl by dou beta, less than 0. Okay, remember this cl is not a lift coefficient. This cl is the, say, this cl is nothing but it's a rolling moment coefficient, just like a pitching moment coefficient. If you remember, rolling moment coefficient. Don't think this is the cl lift coefficient. I hope it is clear now. Okay, I hope it is clear now. Nah? So see, this also can be written cl phi less than 0. This type of question they are asking in your exam. And this will also can be written cl beta less than. If I write the cl beta, that means rolling moment coefficient with respect to the side slip angle. I have told you side slip angle, it's nothing but is equal to the phi only, magnitude wise. So anything you can define, uh, that L changes, L changes with respect to phi. Okay, with respect to phi, L changes with respect to phi, and that will be check dl by d phi less than 0 equal to 0. Okay. Now coming to this is stable. This is nothing but, and this is nothing unstable. Unstable. I hope this one is very clear to all of you. Correct? Now, this is nothing but all about the lateral stability. Similarly, we'll talk about the directional stability. That also I have to write here. Directional stability. Please write down directional stability. Correct? So here we'll talk about the directional. So directional stability, if you talk about the directional static stability basically. Okay. So what is the directional static stability? In this directional static stability, we will talk about the yawing moment. Yawing moment. And this yawing moment you will get about which axis? About which axis? It is the directional axis or is about the vertical axis. Means if this is the, see, If this is the airplane, check everybody. So for this airplane, it is moving in forward direction. This is nothing but vertical axis. Okay, this is nothing but vertical axis here. Check everybody. This is the horizontal axis, and check everybody. So about this vertical axis, we have a yawing moment. And this yawing moment, okay, is always about vertical axis. So yawing moment about directional or about vertical axis or about is also sometimes called z axis. Correct? So here, this is the longitudinal. About longitudinal, we have a rolling. About lateral axis, we have a pitching. Similarly, we have for the directional is a vertical axis or directional axis will have a yawing moment. So if you talk the yawing moment, so what is the control surface? Is nothing but rudder. Okay, control surface is nothing but rudder here. So definitely that control surface is always over the, this is nothing but rudder, is mounted on vertical tail, or in it is mounted on vertical stabilizer. Tail is what basically divided in two part, horizontal stabilizer and vertical stabilizer. On horizontal stabilizer, you have seen there is an elevator. On vertical stabilizer, we'll have a rudder here. Correct? We'll have a rudder here. So now in this case, to think how I can show you, I will show the top view of the airplane. The top view of the airplane, then it will be more clear to you. See, this is the top view of the airplane. Check it. From here, you can understand. And this is what the aircraft check. This is what the, okay. If there is the yaw moment, so the aircraft will be, it will be, check everybody. There will be a yaw. Sorry, check it. No, you understand diagram. This is the airplane when it is yaw about the axis, and see the moment. Moment is what about, see this dot is nothing but axis. This dot is nothing but axis, which is the dot. See this dot is nothing but vertical axis. Vertical axis. So there will be a vertical axis. About vertical axis will have a moment. So if the, if, see this is the airplane, see this is the top view. I don't know you are able to recognize or not. So this is the right side. So this right side is nothing but a starboard, and this side it is called port wing. The left wing is nothing but left side. This is nothing but right side. Please check it. If you see the moment, because of this moment, the aircraft is what? It is the initial. The aircraft should go in this direction. Right? The aircraft should go in this direction, but because of the, you can say, side wind, or because of the disturbance, see, disturbance came and hit to the airplane. This is what disturbance. So the aircraft is what rolled. Sorry, yaw. It is yaw in this direction. Okay? Correct. So here the yaw angle you have. If you check the yaw angle, easily you can understand in this way. So please concentrate, because so many things are there. So you should not confuse about it. And you just check the diagram. Maybe it is not exactly the same what, but at least idea you will get. So this angle is nothing but psi angle. Yaw. This angle is nothing but yaw angle, is denoted by psi. Everybody, please. So now, to make it stable, this aircraft about the vertical axis should have the should have the uh, restoring moment, and that restoring moment is nothing but, see, it is yaw. This is the yaw in this direction. It is because of the disturbance. It is yaw in this direction. Huh? And if you check the to make it store, to make it to store it, to store its original position, there should be a yawing moment. So yaw angle, just make a note of it. Yaw angle is nothing but psi. I should put the notes here first. Okay. So yaw angle is nothing but psi towards starboard. Please concentrate towards towards the starboard, towards the towards the starboard means right wing. Starboard means right wing or right side wing. Towards the right wing is taken. Please check it. This notes is taken positive, and also yawing moment, moment towards the starboard is yawing moment. This is the sign convention. Towards the starboard is taken positive. This is the one sign convention need to remember. Taken positive. So the moment towards the starboard itself, the moment is taken positive. Okay, remember it. Huh? Okay. So if the aircraft is what yawing, at the same time it will roll also. I don't know how many of you have recognized this, but think, the aircraft is what turning one side, or the simple, you can say, you are riding, okay, uh, on bike or maybe cycle, okay. So if you are turning maybe towards left or right, the road is what turn towards left or right. So that time will turn as the road is there, but at that same time you have to tilt your body also. Body also will be tilted. Yes or no? You remember or not? See, where the turning is there, towards the turning, you will turn your body also. So the same thing for the aircraft as well. Even though the aircraft is what yawing means turning towards the left or turning towards the right. Here towards the right wing, if it will turn, then the angle will be taken as a positive. And fortunately, whatever the yawing moment you are going to take towards the starboard, it will also be a positive. Huh? This is the sign convention, especially for the yawing moment. But do you think about the turning towards left and right? That is okay, but at the same time, to turn towards left or right, the aircraft should also roll. Correct? Just like I told you, you are turning towards left or right while you are going by bike or cycle. But once turning towards left and right, that is okay. But at the same time, you also have to tilt your body. Same thing for the aircraft also. It is turning towards right or turning towards left. That is called yawing movement. But while it is yawing, at the same time, it should also roll. It will roll. For that reason, what is the approximately, what is the yawing angle? Uh, this is the first point. Second point, whatever the yawing angle, psi should be also equal to minus of beta. That is nothing but I or beta, both you can take for the yawing moment. Magnitude wise, it is equal but in opposite side. That is the side slip. So beta is nothing but can be used. Okay, beta is also can be used. But remember, this beta is nothing but side slip, and this is nothing but yaw angle. Yaw angle. I hope you all understand. Correct. Now moving up ahead. So here it is very clear. See that direction I have shown. With the help of direction, you can write that what it is called, that equation. You can write the equation. Correct. So it is uh, turning towards the right and turning towards the left. It is turning towards the uh, left, then it will be a negative moment. Turning towards the right, which is the starboard, so it will be a positive. Correct. Turning towards the starboard, it will be positive moment. Correct. All right. So in this situation, if you write the mathematical model of this, write the mathematical model of this. So it is nothing but see, n is the yawing moment. What is the n? Yawing moment. N is nothing but yawing moment. So if you are writing the change with respect to psi or beta, obviously psi and beta both are magnitude wise, it is same only. But if you check the uh, direction, it will be opposite. Anyway, so we have a case one for yawing moment. We have, I will divide in three. Yawing moment change with respect to psi or beta. Okay. So if you are having rho n by rho psi less than 0, so definitely in terms of the beta, it will be just opposite because phi and beta are opposite sign. So it will be rho n by beta positive. There should not be any confusion. Correct. So this type of the condition if there, then the aircraft, okay, directionally stable. Here I will write stable. Similarly, this is neutral, and the third one, rho n by rho psi greater than 0. Then rho psi greater than 0, okay, or rho n beta, rho n rho beta, which is nothing but less than 0. This is the, please remember this, okay? Please remember. So these are the three cases. I hope you all understood that restoring moment. That diagram you understood, it's okay, otherwise I can draw again. It's for your understanding, so it will be more clear to you. Check. I'm just saying the airplane is what somewhat like here. The airplane, everybody. See all of you. Correct. Maybe it is. See the changes if you check. If the yawing moment you have in this way also you can understand. The aircraft is what? Oh, odd like this. See the diagram. So if you check here, this angle is nothing phi. There will be a yaw moment that will be taken. Obviously, this is the vertical axis. So yaw moment will restoring moment will be like this. Yaw moment. This is what is starboard. This is the psi. So if it is yaw towards the starboard, then psi will be positive, and the moment towards the starboard also will be positive. If it is opposite to this, then restoring moment that will be negative. For that reason, you are getting dou n by psi, which is correct. Just now you had seen here, na? Dou n by dou psi less than 0, which is but is stable. So same way, this is nothing but is stable. But psi and beta is just opposite by sine. So this is nothing but this restoring moment is n. So n is what changing with respect to psi, or you can say it is with respect to beta. So that change in terms of psi, it will be negative change. So that will be stable. You need to remember, okay, psi and beta both. Anything they can ask to you. So this is all about the directional stability. I hope you all understood this. Correct, everybody. Now, so in terms of psi and beta, as you have written, then you can draw the graph. Check. This is nothing. See, this is yaw moment, and this is what psi. Check, everybody. So if you see the graph, so the similar thing, just like you had seen this positive negative slope, you can check n by dou psi. Okay? This is nothing but stable. Huh? And the terms of beta, if you write, then here only I am writing, and here it will. So this will be what? Unstable. This will be what? Stable. What? neutral, right? This will be neutral. This is also sometimes denoted by Cn beta. Cn beta less than 0, it's unstable, okay? Please remember. And Cn beta will be, this is just opposite to other different cases, whatever you. So if I show you that all three cases, na, in short, I can write here static stability. It's all about static stability. Okay? If you see the longitude, static stability, lateral, static stability, directional, static stability, right? So, you know, for the stable, for stable, it's a dou m pitching moment with respect to angle of attack must be less, correct? And here the moment, rolling moment, dou L by dou phi with rolling angle must be is the stable. And the yawing moment, dou N by dou psi must be correct or unstable. Here, unstable. Unstable. This is nothing but dou M by dou alpha, dou L by dou phi, N 0, N dou psi. That also, that also can be written as dou Cm alpha less than. This is Cl by dou phi less than. Cn by, similarly dou Cm, you need to remember this. Okay? So all those things, right? In the few books, like if you see the Nielsen, they have nicely they have written this one as a Cm alpha less than 0. They sorry, have written Cl phi less than. This was the Cn psi less. But for this also you can write Cn beta, which is positive rather than this. But I have written this only here also, na? For the unstable, if you see write the Cn beta, so for the Cn beta must be less than 0 for the unstable. That you need to. So these are the things few analysis you can do by your own also. From my side, static stability for the lateral and longitude now. Okay. And